a greatest common factor that we see a little less often, but we definitely want to become familiar with because this will be one of the steps in a method we learn later, is that the greatest common factor is not always just an integer and it's not always just a monomial. In this case, both of our terms have an x plus 3 in common. And this is what we'll try to set up later, but whether it's a single number or whether it's a binomial, because remember, a binomial is ultimately a number. It's just a number that depends on x. If x is 2, 2 plus 3 is 5, 2 plus 3 is 5, they'd have a 5 in common. If x is negative 8, negative 8 plus 3, negative 8 plus 3, I'd have a negative 5 in common. Whatever x is, this would be a number that they would have in common. The same way, I could pull a number out in front, I can pull a binomial out in front. And notice that what I'm left with is the coefficients, 5x and the minus 2. This one's a little bit less easy, a little bit more difficult to check by foiling because we won't be able to ultimately get back to this again. This will be something that we're trying to set up when we have that binomial greatest common factor, when we want to pull out that x plus 3. And it wouldn't matter, we're going to show coming up next, that it wouldn't matter what order we put it in, but it's something that we're allowed to do. And let me show just one more example so we can see something. 7x squared plus times 2x minus 7 plus 5 times 2x minus 7. The fact that both of these terms have a 2x minus 7 in common allows me to pull that 2x minus 7 out in front, leaving me 7x squared plus 5. Now again, if this is not the same, if that's a 2x minus 7, that's 2x plus 7, no go. If that's a 2x minus 7 and that's just an x minus 7, no go. They must be identical. We're going to attempt to set these up later where those are going to be identical, and if they aren't, then we would not be able to proceed forward. We'll see these coming up again in the next few problems.